Download this code from codegive.com, link in the description below. Integrating a modern front-end setup with AEM, a comprehensive tutorial. This tutorial delves into the process of integrating a modern front-end development workflow with Adobe Experience Manager, AEM. We'll cover various aspects, from setting up a build environment to deploying front-end assets to AEM and connecting them with AEM components. Why integrate a modern front-end setup with AEM? Traditional AEM development often involves working directly within the AEM repository, using technologies like HTML, formerly Sitely, for templating and relying on AEM's clientlibs for managing CSS and JavaScript. While this approach has its merits, it can be limiting for complex and dynamic front-end applications. Modern front-end frameworks like React, Angular, and vue.js offer several advantages. Improved developer experience. Modern tooling like hot reloading, linters, and debuggers significantly enhance the developer experience. Component-based architecture. These frameworks encourage a component-based approach, leading to reusable and maintainable code. Performance optimizations. Modern build tools and techniques like code splitting and tree shaking can optimize front-end performance. Team collaboration. Front-end developers can work independently on the front-end without directly impacting the AEM backend. Overview of the integration process. The integration process generally involves these steps. 1. Setting up a front-end project. Creating a separate front-end project using your preferred framework, React, Angular, vue.js. 2. Building and optimizing assets. Configuring a build process to compile, minify, and optimize front-end assets, JavaScript, CSS, images. 3. Deploying assets to AEM. Deploying the built assets to AEM, typically using clientlibs or a dedicated content folder. 4. Connecting front-end with AEM components. Creating AEM components that reference and render the front-end application or individual components. 5. Data fetching, optional. Implementing data fetching mechanisms to retrieve data from AEM's content repository or external APIs. Example, integrating React with AEM. This tutorial will focus on integrating a React application with AEM. However, the principles can be adapted for other frameworks. 1. Setting up the React project. We'll use Create React App to bootstrap our React project. This creates a basic React application. Feel free to customize it to your needs. For example, you might install additional libraries like 2. Building and optimizing assets, Webpack configuration. Create React App provides a reasonable default Webpack configuration. However, you might need to customize it for your specific needs, particularly for handling static assets and defining the output directory. Ejecting Webpack configuration, not recommended. The traditional way to customize the Webpack configuration was to eject Create React App. However, this is generally discouraged as it's a one-way operation and makes it harder to update to newer versions of Create React App. Using React App Rewired and Customize CRA, recommended. A better approach is to use libraries like React App Rewired and Customize CRA to modify the Webpack configuration without ejecting. Create a config overrides.js file in the root of your React project. Modify your package.json to use React App Rewired. Explanation of config overrides.js **** add webpack alias ***. This adds an alias add for the src directory, making imports cleaner. Example, import my component from @/components/mycomponent. *override *. This function allows you to modify the webpack configuration. *config.output.path * sets the output directory to build, relative to the React project. This is where the built assets will be placed. You can customize this to a specific AEM client lib folder if you want the built output to directly land there. *config.output.filename and config.output.chunk filename *. These define the file name patterns for JavaScript files, including content hashes for cache busting. The static /js path creates subdirectories within the build folder, mimicking the structure of AEM client libs. *add posts plugins *configures post CSS plugins, example for auto prefixer and tailwind CSS if used. *add webpack plugin *adds webpack plugins. The example includes a comment about the generate SW plugin for creating a progressive web app, PWA. *override dev server allows you to customize the development server. The example shows how to set up a proxy to your AEM instance, allowing you to fetch content from AEM during development. Build the React application *. This will create a build folder containing the optimized front-end assets. 3. Deploying assets to AEM. There are several ways to deploy the built assets to AEM. *AEM client libs. Recommended use AEM client libs to organize and manage your front-end assets. Dedicated content folder create a dedicated folder under /content to store the built assets. AEM as a cloud service CDN in AEM as a cloud service, you often leverage the CDN and might deploy the assets directly to the CDN. Using AEM client libs. 1. Create a client lib * in your AEM project, typically under /apps/your project /components /your component, create a client lib folder, example client libs, with the following structure. 2. Configure.content.xml * configure the .content.xml file within the client lib to define the categories and dependencies. Categories * this is the unique identifier for your client lib. It's used to include the client lib in your AEM components. Dependencies * lists other client libs that this client lib depends on. 3. Copy assets * copy the contents of the build folder, generated by npm run build, into the appropriate JS and CSS folders within your client lib. Using a dedicated content folder. You can also create a dedicated folder under /content to store your assets. This approach might be simpler for initial deployments but offers less control over asset management than client libs. 1. Create a folder * create a folder, example /content /my AEM project /assets, in the AEM repository. 2. Copy assets * copy the contents of the build folder into this folder. Automating deployment. For a more streamlined workflow, you can automate the deployment process using tools like Maven integrate the asset deployment into your AEM Maven build. *grunt/gulp use grunt or gulp tasks to copy the built assets to AEM. *rsync use rsync command in your build pipeline to deploy the output directory. Example Maven integration, using Maven Resources plugin. Add the following plugin to your AEM project's pom.xml, in the module that contains your components. Important considerations *. Versioning * implement a versioning strategy for your assets, example using content hashes in file names, to ensure that browsers always load the latest versions. This is handled by default with Create React App. Cache invalidation * properly configure your AEM dispatcher to invalidate the cache when assets are updated. AEM as a cloud service * in AEM as a cloud service, use the Cloud Manager pipeline to deploy your code and assets. The CDN is automatically configured to cache and serve your front-end assets. 4. Connecting frontend with AEM components. Now, let's create an AEM component that renders our React application. 1. Create an AEM component *, create a new AEM component, example my React component, in your AEM project. This component will act as a container for our React application. 2. HTML template, my React component.html, create an HTML template for the component. *datasly use.clientlib * uses the clientlib.html template to include clientlibs. *datasly call equals $clientlib.all at categories equals my AEM project.my component * includes the clientlib with the category my AEM project.my component. This will load the CSS and JavaScript files associated with your React application. *divid equals React app /div *. This is the container element where our React application will be mounted. The ID React app is important and should match the ID used in your React application. 3. Initialize React application. In app.js, modify your React application's src/index.js file to mount the application to the container element. Important *, ensure that document.getElementById, React app, matches the ID of the container element in your HTML template. Also, use React DOM/client for React 18 and above to use the new concurrent rendering API. 4. Component dialog. Optional, you can create a dialog for your AEM component to allow authors to configure properties that are passed to the React application. For example, you could add a text field in the dialog and pass its value to your React component as a prop. 5. Data fetching, optional. Your React application might need to fetch data from AEM's content repository or external APIs. * fetching data from AEM, sling models/htl. * sling models * create sling models to expose data from AEM pages or components as JSON. * htl, Sightly use HTML to generate JSON data from the AEM content repository. In your React application, use a library like Axios or the built-in Fetch API to retrieve the JSON data from the AEM endpoint. * example, fetching data from a sling model. 1. Sling model * create a sling model to expose properties of your AEM component. 2. HTML template * modify your HTML template to output the sling model as JSON. *data equals $model.json data at context equals unsafe *. This outputs the JSON data from the sling model, model.json data, as a data attribute on the container element. At context equals unsafe is generally safe here because you're controlling the data. However, always be mindful of XSS vulnerabilities. Consider encoding the JSON for added safety. 3. React component * in your React component, retrieve the data from the data attribute. *use effect * the use effect hook is used to retrieve the data after the component is mounted. *JSON.parse * parses the JSON data from the data attribute. Error handling * includes error handling in case the JSON parsing fails. Fetching data from external APIs * use Axios or the Fetch API in your React component to fetch data from external APIs. 6. Component communication, optional. In some scenarios, you might need to communicate between your AEM components and your React application. Custom events * use custom DOM events to trigger actions in your React application from AEM or vice versa. Example, AEM-React. 1. AEM, JavaScript in your AEM component, example in a client lib associated with the component, dispatch a custom event. 2. React * in your React component, listen for the custom event. 7. Testing and debugging. React Development Server use the React Development Server, npm start, to develop and test your React application independently. AEM Developer Tools use AEM's developer tools, example the CRXDE Lite console, to inspect the AEM repository and debug AEM related issues. Browser Developer Tools use the browser's developer tools to debug JavaScript, CSS, and network requests. AEM Proxying configure a proxy in your React Development Server, using HTTP proxy middleware or similar, to proxy requests to AEM content during development. 8. Progressive enhancement and SEO considerations. Server-side rendering, SSR, / static site generation, SSG. Consider using server-side rendering, SSR, or static site generation, SSG, to improve SEO and initial load performance. Next.js, for React, Angular Universal, for Angular, and Nuxt.js, for vue.js, are popular frameworks that support SSR and SSG. These approaches can pre-render your front-end application on the server and deliver static HTML to search engines and users, improving SEO and perceived performance. Semantic HTML use semantic HTML elements, example article, nav, aside, in your React components to improve accessibility and SEO. Accessibility, WCAG. Ensure that your React application is accessible to users with disabilities by following WCAG, Web Content Accessibility Guidelines. Best practices. Keep front-end and back-end separate. Maintain a clear separation between your front-end and back-end code. This promotes modularity, reusability, and easier maintenance. Use a component-based architecture. Adopt a component-based architecture in your front-end development. This makes it easier to manage complexity and create reusable components. Automate your build and deployment process. Automate your build and deployment process to reduce errors and improve efficiency. Version control. Use version control, example Git, to manage your front-end and back-end code. Continuous integration / continuous deployment, CI/CD. Implement a CI/CD pipeline to automatically build, test, and deploy your code changes. Conclusion. Integrating a modern front-end setup with AEM offers numerous benefits, including improved developer experience, enhanced performance, and a more flexible and maintainable architecture. By following the steps outlined in this tutorial, you can successfully integrate your React, or other framework, application with AEM and create engaging and dynamic digital experiences. Remember to adapt the specific details to your project's requirements and continuously refine your integration process as your project evolves. Remember that with AEM as a cloud service, you will typically utilize its build pipeline to handle the code and asset deployment. You may leverage the AEM site SPA editor to get the editing capabilities, but the setup will vary on project requirements.